For today's lesson, we're going to be looking at solving square root equations algebraically. So in order to do this, we need to remember these important rules that if we square a square root, we get what's under the square root sign as the answer. And the same goes for a cube. So if we have a cubed root raised to the third power or a cubed root cubed, then whatever's under the radical is what we get. So the square root and the squared end up canceling each other out. The cubed root and the cubed end up canceling each other out. So we're going to solve these equations just like a normal equation, but we're going to try to get rid of the radical. So let's look at our first example. So we want to isolate the square root of x. We do that by adding 6 to both sides. This will give us the square root of x is equal to 10. Now, in order to do this square root of x, we need to raise this to the second power. And since we did that to the left side, we're going to also do that to the right side. This squared will take away the square root, and that will leave us with just x, right? X is the thing that's under the radical. And 10 squared is 10 times 10, which is 100. So this first case, x is equal to 100. All right, number 2. Again, we're doing this the exact same way, but now we have a cubed root in our problem. So we're going to add 6 to both sides, and we get the cubed root of x is equal to 10. Well, to undo the cubed root, we're going to take the cubed root of x cubed. So that's going to be 10 cubed. So the cubed root and the cubed cancel out the radical, and we're left with 10 times 10 times 10, which is 1,000. All right, let's look at number 3. So again, we're trying to isolate this square root. We're going to do that by subtracting 6 from both sides. So we get the square root of x is equal to -2. And here we have a problem. If we will remember back to our graph of the square root of x, this parent function, square root of x, remember, it started at 0, 0, and then it went to 1, 1, 4, 2, and so on. And if you remember our domain for this, which are the x values that this could be, they started at 0 and they went to positive infinity. But they never entered into the negative range for the x values. So there is nothing on this side of the y-axis where x is negative, say -1, -2. So the square root of x being equal to -2, we don't have a value for this, right? We don't have it in the domain, and we don't have it in our range. So again, the range is the y values. So all of our y values here are +1, +2, +4, 0. So all of our y values are also from 0 to infinity. I'm sorry, that is 4, 2. So that is a y value of 2 here. All right. So since my domain and my range are both in the positive, we cannot have the square root of x equal to -2. And so because of this, there is not a solution for this. This has no solution. Okay, let's look at number 4. So we have the cubed root of x plus 6 is equal to 4. Well, again, solve these the same way. We get the cubed root of x is equal to -2. Now, our cubic function the parent graph for a cubic function, the cubed root of x, behaves a little bit differently. So let's stick with our rule here, and let's raise this to the third power and raise this to the third power. Well, that's going to get our radical to cancel, and we're left with x is equal to negative 2 times negative 2 times negative 2 is negative 8. So the cubed root of negative 8 plus 6 is going to equal 4. All right, let's look at number 5. So for this one, we want to isolate the radical. So we're trying to isolate all of 3x plus 5. That is what's under the radical. Well, we're going to do that by adding 2 to both sides first. This is going to give us the square root of 3x plus 5 is equal to positive 1. And here, since this is the square root, we're going to square both sides. That's going to allow us to cancel out the square root, which will leave us with whatever's under the radical, whatever's under that square root. So we'll have 3x plus 5 equals 1 squared. 1 squared is 1 times 1, which is just 1. And so now we have a very basic equation that we can continue to solve. We're going to solve this by subtracting 5 from both sides. This will give me 3x is equal to negative 4. Divide by 3. Divide by 3. X is equal to negative 4 over 3. Let's look at example 6. So we have 6 minus x. The square root, the cubic root is already isolated. There is nothing to add over to the other side like we had in this case, in the previous case. So let's go ahead and cube both sides since we are trying to cancel out the cubed root here. So we're going to be left with the 6 minus x is equal to negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is a positive 9. Positive 9 times negative 3 is a negative 27. So we end up with a negative 27 as the result for negative 3 raised to the third power. So here we have to get x by itself, and so we want to isolate the x. We're going to do that by subtracting 6 from both sides. So you get a negative x is equal to a negative 33. Since negative x is equal to negative 33, that means that positive x is equal to positive 33. Okay, let's look at one more example where we have a square root on both sides. Well, since the square root is isolated on this side and it's isolated on this side, what we can do is we can square both. So we're going to square this side and we're going to square this side. How will that help us? Well, that's going to allow our square root and the squared to cancel. That's going to leave us with 4x minus 7 is equal to 3x plus 9. And here we're going to solve for the variable. So at the end, we're going to get x is equal to some number. Well, let's move the 3x over by subtracting 3x with our terms that are like terms. 3x minus 3x is 0x. 4x minus 3x is 1x. Okay. Now, since we move the x's to the left, we need to move our number, negative 7, over with the 9. And when we move this over, we're going to add 7 to both sides. So we get 9 plus 7, which is 16. So we have a 1x is equal to 16. So this will be a way that we can solve radical equations algebraically. The key to this is remembering that the square root squared is just what's under the square root, and the cubed root cubed is what's under the cubed root. So we can undo the radical or the root with either the squared or the raising it to the third power. And this could also be for a fifth root of x. If you raise that to the fifth power, you're going to get whatever is under